Let's kick off. And by the way, there will be an opportunity to ask questions right at the end of the presentation, so feel free to ask those either through the panel or online at the end, and we'll bring you all into conversation online at the end of the presentation. Over to you, Liam.
Thank you very much, Kevin. So my name is Liam Pickard. I work at ThinkS3. We're one of Tenzig's partners, and obviously we've been working with them for quite a while, delivering VDI, thin client and zero client solutions into a number of our clients in a variety of user bases. What I don't want to do is make this webinar about us. I'm going to keep this quite short and sweet for you all, just to give you a bit of an overview and a flavour of who ThinkS3 are. So if we can go to the next slide, please, Kevin. So ThinkS3 are a hybrid infrastructure solutions and service provider. We actually started about 14 years ago in the virtualization space, working with people such as VMware and Microsoft with Hyper-V. And over time and over the years, we've always maintained a leading edge element to our business, which has led us to be this hybrid infrastructure provider that we are today. We were actually one of the small global number of Microsoft Tier 1 cloud services providers, which we were invited into by Microsoft at the early stages to help them develop that program. And we remain today one of the few VMware partners where they actually ask us to provide professional services both to them and on behalf of their customers as well. We're a privately owned company, and we continue to invest in our growth and in our innovation, and this shows extensively in our technical team, who are highly accredited. There's always somebody out learning the next thing and testing the next thing and making sure that we've got the skills to bring to the market that you need. And as you can see there at the bottom, we work with quite a range of organisations, from people such as ZSO in the charity sector through to people such as Sumitomo in the banking, and in education with many of the colleges as well as the universities of Cambridge and Oxford. So we've got quite a vast range of experience that helps us cover everything within that world. So, you know, data center services, backup, storage, disaster recovery, as well as the desktop element. Next slide, please, Kevin. So, as I said there, we just give you a brief sort of synopsis of where we help and who we work with. You can see that we really try and just cover off the core competencies required to the modern day business. So we work with the leading suppliers. We're always looking at new technologies. What you're seeing there is probably the core of what we do, but there are other services and other elements that work in and around that. So we'll always look to work with companies to deliver the right services through. Next slide, please, Kevin. Just gives you a real brief overview of how S3 work. So we work on business case scoping. We're not your typical tin shifter, so we do believe in coming in, understanding your business case, understanding what you're looking to achieve, and then working with you through the right tools, so be that assessments, workshops, deep dives, to help you get the right solution design, prove those solutions before putting them into practice. Which is where we like to work with all of our clients. We come from a consultancy background rather than a solutions deployment background. So it's, for us, very much about making sure that the service adds value to the business. And you can see here from a couple of headlines taken from our customer satisfactions recently that we do that very, very well. We're always looking to add value, and I'm pleased to say that 50% of our clients have rated ThinkS3 as exceeding expectations when delivering value into those projects for them. If we could go to the next slide, please, Kevin. So not just implementing and designing and helping people understand their solutions, a big part of what we do is making sure that that roadmap of technology that we help you understand and help you get onto can be supported, can make sure you've got all the elements you need, be that a full-blown managed support service or just looking at small areas where you need a little bit of help. Should it be consultancies days, a bit of a risk assessment, just making sure that everything's ticking over and that you plan for the future ahead to get the best out of the technology and the best out of your time. Nobody likes firefighting, so where we can, we'll help do that for you. Next slide, please, Kevin. And just very, very quickly, if you want to find us, you can find us online at www.thinks3.co.uk, on Twitter at think_s3, and obviously you can see our telephone number and our general email there. So I just want to say thank you very much for all of you attending today. I've seen the slide deck that Kevin's about to go through to you. There's some really good information in there. I certainly know that our technical team were pleased to have a look and get some learning out of it themselves. I hope you get just as much value as they did. As Kevin said, there will be a chance for some Q&A at the end, so if you do have any questions, please raise them to us, and I hope you enjoy the webinar. Kevin, I'll hand over to your good self and let you do what you do best.
Thanks very much, Liam. Appreciate the background there to ThinkS3, who, as mentioned, are one of Tenzig's valued partners, and as we said, we'll take over now and go over the PCoIP and Blast Extreme demystifying. What I want to just start to cover is an overview and a background on protocol delivery for VDI, because whilst it's something that we live and breathe every day at Tenzig, it's probably something that you guys don't necessarily study so closely. So I thought it'd be good to give a whole background on that first, so that we can then break down PCoIP and Blast Extreme in a little bit more detail. So we're going to start with graphics rendering, and graphics rendering is really an important piece and has become much more relevant to VDI in the last couple of years, since the introduction and the adoption of server-based graphics cards, including products like NVIDIA Grid. So the graphics rendering is really about server-based graphics rendering. So it's often thought that server-based graphics rendering is 3D workloads, so things like 3D or CAD type applications, but it has opened up scope a lot more to include everything in terms of things like 2D multimedia, so where users are playing back 2D videos, whether it's local media files, whether it's opening browsers and going to sites like BBC, sites like YouTube. These are all graphics-based content that can be utilized very well in server-based graphics cards. So the obvious player in this market space is NVIDIA with the NVIDIA Grid cards, but there's also some other vendors that have currently recently joined the marketplace. So we have AMD with the FirePro cards, and we also have Intel with their latest Iris Pro graphics, which are part of the latest Xeon processors for servers. So like I say, very, very relevant and important piece to modern day VDI. We then have the encoding and the decoding piece. So whereas the graphics card or the graphics engine is responsible for rendering that display, again, whether it's 2D or 3D workloads, when we're connecting with VDI and server-based computing, there's a process involved to actually encode that content, so that once it's encoded, it can be sent remotely to the client device that's displaying that content remotely. So the encoding is where, as we mentioned, we're wrapping the protocol. So in this case, we're talking about either PCoIP or Blast Extreme, and that's natively or by default encoded in the server's CPU, and we're generally encoding the display and the audio, as I said, for preparation to deliver that to the client device. Now, there's two general techniques for doing that. We either encode that protocol in the server's CPU, or we can do it in a separate hardware encoder, and there's options for both PCoIP and Blast Extreme. And some of the other process involved in encoding that information is that we compress it down so that we're not using up tons of bandwidth, and importantly, we also encrypt that data as well, so that it's not available for eavesdropping, etc. And then once it's encoded, we send that to the client device via the network, so it's using TCP/IP. So the encoding part is all essentially done on the server side. And again, it's important to think about that for VDI, because with VDI, you're essentially remoting all of that workload to the server. So that all of that workload would historically have been done on the PC, and this, again, you're now remoting that to the server, and then additional to those existing workloads, you're also then having to think about the encoding overhead that natively will also have to be done in CPU in addition to that standard workload, and that's on top of rendering as well. So if you're rendering on a separate graphics card, then that's great, but equally there are quite a lot of VDI deployments that will do graphics just on this server's native CPU. So there's all these different workloads that can quite easily and quickly overload the server in terms of spreading the load and increasing density, etc. The decoding side of things is the important piece for the client device. So it's the client device, i.e. either the thin client or the PC or the tablet, that's having to decode that protocol before it displays that display or audio to the user. And similar to the encoding side, the decoding is performed either in CPU, which is ultimately a software technique, or a hardware decoder. And again, there's options for both PCoIP and Blast Extreme, as we'll discuss. So we've talked already about the concept of hardware and software. So there's techniques for both essentially, and it's important to explain the advantages and disadvantages of both. So the advantages generally of hardware are the fact that it improves performance. So that's ultimately the goal, that you want to improve the performance as much as possible, and that is generally achievable by either encoding or decoding in hardware. And one of the other benefits is the fact that when you're encoding or decoding in hardware, you're ultimately looking at increasing user density, and the reason for that is the fact that, again, by offloading the encoding overhead, for example, to a separate hardware encoder or card, you're freeing up that general purpose CPU to deal with the everyday workload tasks, such as displaying Excel spreadsheets, PDFs, or the 3D applications if it's a 3D workload that you're dealing with. And other advantages are that it can potentially decrease latency, so whether it's latency in terms of the encoding time or the actual delivery from A to B. Disadvantages of hardware v software: one obvious one is the fact that it potentially does require additional hardware and cost, and that can also incur additional licensing costs potentially as well, and additional expense as well, that it can in certain cases add additional latency and bandwidth, and we'll see some examples of that later on. But for the main part, where the cost is really the main issue that comes into play with hardware encoding. So taking into account the additional hardware cost and any applicable licensing costs, ultimately the hardware encode decode option is preferable for both PCoIP and Blast. It's also important to talk about the methods of compression. So we said before that when we encode the display, we're ultimately looking to compress it down so that we're not using up a ton of network bandwidth as we send it across the network. So there's generally two techniques, and the first one that we'll talk about is the lossy compression model. So this is ultimately something that's irreversible. So what we mean by that is that it's taking something like an image, and it's looking at pixels essentially that are the same, that can be shared and compressed down, and it's making the compression is making basically an assumption that pixels are the same color, the same contrast, etc., to ultimately reduce overhead in terms of bandwidth and encoding time. But ultimately that image quality from source to destination is changed, and it's irreversible. So when we decode, that image is essentially different from what it was in the source. And the concept of lossy compression, that it's perceptually lossless. So that means that when a user is looking at that either image or video to the naked eye, it should be almost perceptually lossless, that image quality hasn't changed from what it was in the source. You then have lossless compression, and lossless compression is the reversible model. So you're still compressing the data, but you're basically retaining the image as it was in the source to the destination. And this is generally used in environments such as CAD and medical imaging, where you need that high-level image quality. And to give you an example, we're going to come onto this in more detail, but for the lossy compression, the Blast Extreme protocol is based on lossy compression by default, and the PCoIP protocol is based on the lossless compression by default. But both, as we'll see, can be configured to work with either lossless or lossy. And again, we'll look at examples of where each one can be better. It's also important just to cover how the protocol gets from A to B. So again, we've talked about wrapping it, we've talked about encoding it. So how does it get from A to B? So there's generally two techniques. There's TCP and UDP, and if there's any network engineers that are on the webinar today, then I'm sure you'll be familiar with TCP and UDP. But for those that aren't, in a very basic form, TCP is a connection-oriented model, which basically means that when the packets leave the source and they go to the destination, there's some error handling and servicing techniques in there to make sure that those packets arrive error-free. And if packets are dropped along the way, that the source will regenerate and resend those, so that we're not having a situation where we're dropping and losing packets, which in the VDI world, when we're sending display data, will ultimately result in certain artifacts, certain sections of the screen appearing lost to the user. So there'll be black sections to the screen, etc. UDP, on the other hand, is a connectionless model. So this means that the source that sends the packets are sent without any error handling or sequencing at all. So the source that sends these packets just makes an assumption that the network will deliver those packets without dropping them at any point along the way. So whilst it's good in the sense that there's less overhead involved because we're not doing any error handling and sequencing, again, it is making an assumption that the network will guarantee that those packets get from A to B. And UDP is generally used for services like voice over IP and also video IP. So the overhead is less, but it does require generally a well-configured network, so a managed network that implements things like quality of service to guarantee packet delivery. And again, to give you an example, Blast Extreme works based on TCP by default, whereas PCoIP delivers packets based on UDP by default. So again, there's some differences there between both protocols, and again, we'll drill down on those later. So that's given you a bit of a background overview to protocol delivery. Hopefully that was helpful either to fill in some gaps or give you an overview. And now we're going to go into more of a drill down into PCoIP firstly, and then Blast Extreme, and hopefully fill in some more gaps in the meantime as well. So a bit of a background onto PCoIP. So PCoIP is a proprietary remoting protocol which was developed by Teradici, and Teradici was formed in 2004, and they partnered with VMware in 2008. So the protocol behind VMware View as it was, or VMware Horizon today, came from Teradici, and the PCoIP protocol within there was essentially a remoting protocol developed by Teradici. Teradici develop hardware and software-based products, and I think it's important to state that Teradici as a company do have separate products, so they don't just wrap the protocol into either VMware Horizon or VMware View. They do have some other remoting products that enable the remoting of workstations, and even today the latest products that they have are some clever cloud-based software for, again, remoting protocol delivery from client endpoints to remote cloud-based desktops. Bit of a background on Blast Extreme. So Blast Extreme, it was a remote, or is a remoting protocol that was developed by VMware. So whereas PCoIP was essentially OEM'd or inherited by VMware to be incorporated into VMware View and VMware Horizon, Blast Extreme was developed exclusively by VMware. So it was established originally from Blast. So there's Blast Extreme and there's Blast. So what's the difference? So Blast is the protocol that was originally there to provide a way and means of providing HTML access for VMware View and Horizon. So essentially it was a way of not necessarily using a VMware client either in Windows or Macs. It was a way of being able to open a browser such as Chrome, access your VMware Horizon server, and to be able to gain access to desktops and apps using the browser. So that protocol was essentially enhanced by VMware to be incorporated into their standard VMware clients. So Blast Extreme was first made available in VMware Horizon 7.0 and equally Horizon Client 4.0 for platforms such as Windows and Linux, etc. Blast Extreme is a hardware and software based model, and they're the kind of techniques that we're going to discuss. So you can do encode and decode both in hardware and software. Now, you might be asking the question already as to what's the reasoning behind Blast Extreme. The primary reason behind Blast Extreme was that it was available. It was made available to provide basically a solution for certain areas where PCoIP wasn't necessarily suitable, and that included firstly mobile devices. So things like Chromebooks and laptops, devices that essentially ran from battery. And Blast Extreme, because of the fact that it's based off of an industry standard technique versus PCoIP, which is essentially proprietary, it's basically better for those types of platforms that run off battery to extend battery life, etc. It was also aimed at providing a means of connecting to VMware remotely through lossy networks. So as users were connecting from home, they were connecting across the internet, across the cloud. Blast Extreme was provided essentially a better method because of the fact that it connected via TCP versus UDP in the case of PCoIP. So there's some of the reasons as mentioned beforehand. So in terms of encoding for PCoIP, let's just look at some of the differences and then we'll compare that to Blast Extreme as well. So encoding with PCoIP, it's important to state first that PCoIP does have multiple codecs and they're able to provide a way and means of encoding that protocol based on the use case or the user requirements. So if the user's displaying essentially office productivity type applications such as PDFs or Excel, then there's a codec for that type of use case. Equally, if the user's looking to play back video streams, there's codecs for that, and so on. So it's a multiple codec based protocol. As mentioned, when you use PCoIP by default without any configuration or tuning whatsoever, PCoIP is based on lossless. So again, it's that reversible model. It's providing that image quality from A to B. And UDP again is the default model. So it's that connectionless model. The protocol is encrypted, so it uses AES 256-bit encryption. And importantly, the protocol is configurable. So whilst it uses lossless compression by default, you can turn it into the lossy compression, and you can adjust and configure things such as the image quality, the frames per second, bandwidth, and that ultimately enables you to configure and scale PCoIP down to some degree to help if for example, you're in limited bandwidth environments, or you want to tune it just for the use case that the use case is more or less about task worker or knowledge worker loads. In terms of encoding PCoIP, if you just install VMware Horizon into a vSphere environment without any additional hardware, then as we said before, the protocol will encode onto the server's CPU. So again, think about the fact that the server is now having to deal with lots of user workload tasks in addition to encoding that PCoIP protocol. So in a way of increasing the density, in a way of offloading that overhead of encoding PCoIP, there's a separate hardware card called the Apex 2800 LP card. And there's some important things to state about here. There is a slide later on where we'll drill down into a little bit more detail, but some key points here to talk about the Apex card are firstly that it's a separate card, so it's PCIe based, and it installs into the server alongside CPU, etc. Now, a key feature of the Apex card is the way that it encodes the protocol is dynamically. So that means that it will dynamically offload virtual machines as required. So it's not in a scenario that it's a persistent rule, or it's not a scenario that as soon as a virtual machine is turned on that it's using overhead on the card. The Apex card is intelligent enough that it will basically listen to streams, and where required it will offload those encoding streams from the CPU towards the card, and it can do that dynamically. It's ultimately based on the user's resolution, but it will do that typically up to 64 virtual machines in any one server, and you can have up to 2 cards in a single server for encoding up to 128 virtual machines. It is important to state, and this is relevant when we come on to encoding of Blast Extreme, that whilst the Apex card is responsible exclusively for encoding, it can work alongside GPUs. So that's again important if you are doing a deployment with server-based GPUs, again either NVIDIA, the AMD Fire Pro, or the Intel Iris Pro. So whereas the GPU card is dealing with the rendering, once the content is rendered in the server, it's then offloaded to the Apex card, which encodes the protocol. So you've got 2 cards essentially working together and ultimately increasing the performance to the user, whilst also increasing the user density by the fact that it's offloading the rendering task in the case of the graphics card, and the encoding in the case of the Apex card away from that server CPU. Comparing that to Blast Extreme, so likewise or similarly to PCoIP, Blast Extreme is a multi-codec based protocol. So the native form that it encodes the protocol for Blast Extreme is it uses H.264. So H.264 is an industry standard video based codec, and this codec is used for lots of purposes. So I'm sure the audience today have got things like Netflix, Amazon Prime, etc. So those same services use H.264. It's a very good way of remotely delivering video content. So VMware are essentially using that same type of codec for delivering or remoting that display session within VMware Horizon. And as mentioned, H.264 is a lossy compression. So ultimately, a key difference between H.264 and PCoIP in its native form is that it is lossy. So it isn't good for certain use cases like CAD and medical imaging, etc. Now, if you do want to use Blast Extreme in the lossless mode, so again, that's where you want to retain that image quality, then it is configurable. So you can configure Blast Extreme to use their image-based codec, which is essentially either JPG or PNG based, and that can also be used as a technique for supporting devices that don't support H.264, which we'll go on to in a little bit more detail later. Blast Extreme out of the box will work via TCP, but it can also be configured to work with UDP similar to Teradici and PCoIP. And again, there isn't a magic bullet here as to TCP or UDP necessarily being better. UDP is about lower overhead, but does require a well-managed network to guarantee that packet delivery, whereas TCP, because it has that error sequencing, the source can verify and regenerate those packets if need be. So Blast Extreme can ultimately tailor to both in each scenario. Similar to PCoIP, the protocol is encrypted either with AES 228 or 256, and similarly to PCoIP, the protocol is configurable to the same sort of degree. Now this is where it's very key to talk about the different encoding techniques for Blast Extreme. So where we're encoding Blast Extreme in software, so again that's talking about the host, the server CPU. So we're doing that in software or CPU if it's H.264, and that's where an NVIDIA grid card isn't installed, which we'll go on to later. And equally, if you switch Blast Extreme to the image codec, the JPG PNG, that will inherently revert to encoding Blast Extreme in CPU. So you would ultimately see the density reduce, and you would ultimately see the server CPU increase if you're using H.264 in the software form or the JPG PNG image encoder. Onto the hardware side, so this is in comparison, I guess, if you like, to the Apex 2800 card. If you're encoding Blast Extreme on something like an NVIDIA grid card, it's supported for H.264 only. So the native form of Blast Extreme does get encoded onto an NVIDIA grid card, which we'll talk about in the next slide. And to do that, it basically leverages H.264 encoders on those NVIDIA grid cards. So let's look at those on the next slide here. So I'm not sure how much background the audience today has in terms of NVIDIA grid cards, but as we talked about earlier in the presentation, the concept and the introduction of NVIDIA grid was all about adopting graphics workloads for VDI. So it was being able to leverage and turn high-end, heavy workstations that were dealing with graphics workloads such as 3D and CAD type applications, and being able to turn those into VDI using NVIDIA Grid. So these are server-based graphics cards which can give up basically shared resources to users in terms of workloads. And originally there was the Grid K1 and K2 cards, and today we have the Tesla-based cards where we have things like the M6, the M10 and the M60. So where they were introduced predominantly for graphics workloads, it's become clear that server-based graphics cards almost serve a complete purpose for VDI, because again, they're not just used necessarily for 3D and CAD environments. They can be used also to increase performance and increase density for users that require even things like video and rich multimedia experience with things like browsers and also things like PowerPoint applications, etc. But ultimately, the limiting factor of server-based graphics cards are that they potentially are expensive, and there are additional things to consider when you add in graphics cards as well, as we'll discover. Now, the purpose of today is to really again talk about encoding for Blast Extreme. So as you'll see on the cards here, the thing that's highlighted in bold here is that on each one of the NVIDIA grid cards there are essentially encoder streams. So they're separate dies, they're separate resources on the card to the general rendering side of things. So if we look at the K1 and the K2, there are 6 encoder streams and 12 in the case of the K1. And they're basically used and assigned. So wherever we have a virtual machine that's turned on and we're engaging in Blast Extreme, these encoder streams are generally used. And whereas in the case of the encoder card for the Apex card, where it can dynamically offload that protocol, Blast Extreme is different in the sense that as soon as the virtual machine is turned on, it will be using an encoder stream whether it's turned on or off. So you'll notice in the case of the Tesla cards, these are the second generation boards that the number of encoder streams has obviously increased, and that's because of the fact that the NVIDIA, the second generation cards are really designed around the whole encoder stream for Blast Extreme. So something like the Tesla M60 card can encode up to 36 streams. Now, another thing that's important to mention here is that whilst this is 36 streams, if you have something like a multi-monitor type situation, so you've got your users are equipped with 2 monitors, for example, that's going to reduce down. So in the case of the M60 card, you'd be looking at being able to manage 18 users across one board. So that's one factor to consider with Encoding Blast Extreme. It's the number of encoder streams that are on the card. The additional thing to consider with encoding the Blast Extreme protocol and the NVIDIA grid cards, specifically around the 2nd generation boards, are the licensing costs. So let's just explore those. So in terms of the pricing model and the licensing cost for the NVIDIA grid card, you've got the not only the capex cost of buying that card, but you've then got an OPEX model of basically requiring a license for each user that is entitled to use a piece of that grid card. So the licensing model has changed from its original form. So there was some restructuring of the pricing from NVIDIA, and the pricing that I've included here is taken from the source that we can see here. So it's the package and licensing guide, which I think was made available around December 2016. Now it is important to state here that this is suggested pricing only. So wherever if you decide to purchase the grid card from ThinkS3, then obviously pricing can be obtained from those guys. But essentially this is suggested pricing only. So let's just discuss this for a moment, just so that everybody can hopefully get a bit of an idea and a grasp of the different licenses available. So as you can see, there's 3 different models available. We have firstly the virtual apps license, and the virtual apps license is used for RDSH workloads. So this is where you're using VMware Horizon and you're connecting essentially to a server, either in the case of an RDSH based desktop or application. You've then got the virtual PC. So this is where you're using VMware Horizon with VDI, but the profile that you assign to the user is such that it's aimed at providing a performance that is an equivalent of a knowledge worker, power worker type user. So we mean by that it's a user that wants to come in, they want to be able to play video, they want to be able to go to their browser and open YouTube and get an experience which is similar to a typical average size PC. At the high end, you've then got the virtual workstation license. So this is a high-end workstation replacement. So these are the users that have shifted from a multi-thousand-pound PC desktop where they're doing specifically 3D and CAD-based workloads, and they're coming to VDI and they're coming to the NVIDIA grid card with the most prolific profile in terms of horsepower to deliver to that same experience. We then have the different types of licensing for each one of those models. So essentially you have either annual or perpetual. So let's start with the perpetual first. So the perpetual is essentially a lifetime license. So when you buy the card, if you choose to buy in conjunction with the perpetual license, that means that license is there, as we say, for lifetime. The other thing that is required with the perpetual license is sums. So sums is the support, upgrade and maintenance part of the license, and you are required to take year 1 sums in conjunction with the perpetual as well. So ultimately, if you went for virtual apps, you'd be looking at $25 per user. If it was virtual PC, you'd be looking at $125 per user, and so on. And then ultimately it's down to you whether you choose then to buy the sums for years 2, 3 and onwards. If you compare that to the annual license is, as it states, it's an annual renewable license, but the annual license does include sums. So it's quite easy to work out the maths there as to which one might work out better, whether you went with the annual or perpetual. But do consider this if you are looking at deploying Blast Extreme. If you are looking at ultimately wanting to encode that protocol in hardware to increase user density and increase performance, you are going to have to consider those additional costs of firstly the card and the licensing costs on top as well. If we compare that to the Apex card, the Apex 2800 card, as I said before, the number of displays that it supports is ultimately based on the user's resolution. So the most typical resolution we come across these days is 1920 by 1200, and it's in landscapes. That was the 64 number of displays that are supported by default. And again, remember with the Apex card, it does work dynamically. So in the case of the NVIDIA card, where it's about the one-to-one model, the Apex card is a dynamic model. So ultimately it can be more scalable with the Apex 2800 card. But also importantly with the Apex card, do remember that it is compatible with your GPUs. So whether you choose to use an NVIDIA Grid K1, K2 strictly for rendering, or even if you choose to consider things like the AMD Fire Pro and the Iris Pro, the Apex card can work with any one of those, and it will offload the encoding side of things. And the system requirements we've listed here as well. Just going to now focus on the decoding side of PCoIP. So in terms of decoding PCoIP, we require VMware Horizon clients, Windows, Linux, etc. And if we're decoding the PCoIP protocol in software, it's again decoding that protocol in CPU. Now, a downside to the PCoIP protocol, because of the fact that it's proprietary, if you are decoding that in CPU, it is an expensive protocol in terms of how much horsepower it needs. So typically if you are using an endpoint such as a thin client, such as a laptop, then generally you are recommended to use a dual or a quad-core CPU to give you that good level of experience. In terms of the hardware decode side of things, there are the Teradici Zero clients that Tenzig as a vendor offer, and ThinkS3 as our partner can offer you pricing and models on the Teradici Zero clients as well. But the Teradici Zero clients are there to provide the greatest user experience for PCoIP. So the Teradici Zero clients effectively have a piece of silicon on there that's designed exclusively for decoding the PCoIP protocol. In terms of decoding Blast Extreme, so again on the client side for Blast Extreme, I mentioned before that it's supported from Horizon clients 4 onwards, and if you're using the VMware Horizon client for Windows or Linux, for example, when you connect to VMware Horizon and you specifically looking to connect with Blast as a protocol, it will be done in software, so it'll be done on this client CPU. If the client doesn't support H.264, and or if the administrator has configured Blast Extreme for that JPG PNG model, where it's ultimately an image-based codec. On the hardware side of things, it will decode in hardware if you have H.264 compliant hardware. Now the good news on the client side of things is the fact that, as I mentioned before, H.264 is very much industry standard. So pretty much any product you buy, even up to sort of 5-6 years old, generally will be H.264 compliant. So whether it's Intel based, AMD, ARM, all of these cheap inexpensive clients out there will support hardware based decode by default, which again is good news because it reduces the cost, and it's ultimately about giving a good level of performance. Now, something that is just worth mentioning, it did change recently, that if you are again looking at either single monitor or multi-monitor loads, if you're dealing with just single monitor loads, then that again will encode and decode in hardware by default. But if you are looking at 2 or more monitors and you're looking at deploying Blast Extreme, make sure that you're using Horizon 703 onwards, and likewise the Horizon Client 4.3 onwards, because that was the first version where the hardware encode and decode was supported for Blast Extreme with H.264. Okay, so I've done a hell of a lot of talking now, so what I really want to give you an overview of is how well the protocols compare. So what we did fairly recently was we set up a lab environment to basically put the two protocols side by side and see how they fared depending on various use cases. So in terms of the lab setup, we set up a very modest VDI environment running Horizon 703. The Horizon 703 was running on a server 2012 R2 server, and we configured basically a desktop pool that was configured to support both Blast Extreme and PCoIP. For the virtual machine that we were connecting to through Horizon, we were using Windows 10 Professional, and we set the virtual machine up with 2 vCPUs, 4 gig RAM, and we also installed the latest Horizon agent at the time, which was 4.03. And on the client device, we used one of our Tenzig Blast 0 clients, which supports both Blast and PCoIP. And with that, we were running the latest Horizon client at the time, which was 4.3, and we were using H.264 decode. In terms of the type of load that we were looking to gather some feedback and information on, this is a summary of essentially what we had. So for each use case, we did a 20-second interval of either scrolling through data that was available to us in its specific application, and also playback of specific video content. So we included in this Excel, so we loaded a pretty rich spreadsheet, which was made up of 8,500 rows and 17 columns. We also used a PDF, a well-known one that's known to us for taxing any video environment. So it's the iPhone user guide, which is a 25 meg PDF, and it's graphically rich. So it contains lots of images and lots of text, and in the past has been known to grind to a halt any kind of VDI deployment. Equally, on the browser side, we use Google Chrome, and we connected to, again, a well-known website such as Daily Mail, which is very rich. It's basically a single page website that contains images, video, and lots of text, again, to try and tax it to its needs. And then finally, we played the Avatar 1080p trailer through VLC, again, for taxing this. So I think it's important to state here that each one of these is designed to tax that protocol as much as possible. So ultimately, the results that you're going to see are really worst case scenario for each protocol. So it's fair to say they're not typical of an average user's workload, but at least it does give you a good idea of how each will scale out in terms of overhead. So when we were testing this, we tested with PCoIP in its default form, which again is built to lossless. We also tested Blast Extreme in its default form, which is lossy, and then we configured each one to simulate as closely as possible the other one. So for PCoIP, we disabled the build to lossless, and for Blast Extreme, we turned on the build to lossless, just to give you an idea of how the protocols compare. So this is the first example, and it's just important to explain the information that we're seeing here. So on the left-hand side, this is each use case. So this is PCoIP build to lossless off. So this is when we configured PCoIP to simulate the build to lossless in the case of Blast Extreme. This was Blast with the PNG encoder. So this is where we are basically configuring Blast Extreme for the build to lossless. And then these are the two protocols in their default form. Now, the other thing that we're looking at here, so the black results here are the peak CPU load of the server. So this is where we see any particular peaks during that 20-second sample, and then in the orange we have the average CPU load. And what we're looking at here is we're not looking at the server's overall CPU load, we're monitoring specifically the encoding task. So if it's Blast Extreme, it's vmblastw.exe, and if it's PCoIP, it's this particular executable here, the PCoIP server Win32 process. So do remember that in addition to this encoding task, you would also be looking at additional overhead. So in this case, you'd be looking at additional overhead for Excel and anything else that the virtual machine and the server was having to deal with at any one time. So it's fair to say that Excel is a very intensive application. If you're loading it with a rich spreadsheet with different colored cells, with lots and lots of data, and you're scrolling through that as quickly as possible, then it will create a lot of load in terms of encoding and just general overhead for Excel. So that's why we see in the results here a very heavy load for both protocols. But I think you can see here that that Blast Extreme, as an average, has performed slightly better in terms of overhead versus PCoIP. But interestingly, if we revert Blast to the build to lossless, we can see that as an average it has increased quite significantly from its default form. So you can quite quickly get to see here that depending on how you configure each protocol, you can vary the overhead quite significantly. If we look at the same use case, what we've also done is we've also monitored the actual bandwidth that's being used between the source and the destination, so between the server and the client endpoint. So again, we've got a similar outcome here, or output here, that the black is the peak bandwidth at any one time and the orange is the average. So it's really the average that's more important, because the peaks were just very brief spikes in the trace. And again, what I should also state here is that this isn't the overall bandwidth, this is specifically the display. So in the case of Blast, it's TCP 22443, and in the case of PCoIP, it's UDP port 4172. So again, similarly to the server's overhead in terms of CPU, we can see that the overall bandwidth used for Excel was, in terms of average, was actually less to some degree against PCoIP. And but interestingly, this is where, if, for example, we configured PCoIP to the build to lossless, or we disabled it, that it in the average side of things, it did reduce that considerably against PCoIP in its default form, and matched that very similarly with Blast Extreme. So in the mainstream of things there, I think it's fair to say that for Excel, the Blast Extreme protocol has seemingly fared better in terms of overall bandwidth and CPU load. In terms of encoding for the Adobe Reader, so again, this is the graphically rich PDF, the iPhone user guide that we looked at. We can see some different results here. So we can see that PCoIP in its default form actually fares better, both in terms of peak and average, against the Blast Extreme. And similarly, if we go to bandwidth here, we'll see that PCoIP again is faring better. And again, think back to when we talked about the kind of history behind both protocols. In the case of PCoIP, it has multiple different types of codecs to work based on whether it's text loads, whether it's image loads, whether it's video loads, whereas Blast Extreme is essentially a video-based codec. So the fact that it's video-based codec means that it probably doesn't scale quite so well in terms of things like Adobe Readers, in terms of things like office productivity workloads, where it's really essentially text and white background that the protocol is having to encode. And again, similarly in the encoding side for Google Chrome, the protocols here are almost very similar in terms of the average. For the peak, Blast Extreme, interestingly, was slightly higher than PCoIP, but as an average, they were obviously very similar. What is interesting here is in terms of the bandwidth for Chrome. You can see in the peak for PCoIP, it was actually substantially higher than Blast, almost double, whereas the average was actually less. Now, I think it's fair to say here for PCoIP that in the case of Google Chrome, where we were looking at the Daily Mail site, the Daily Mail site natively does include some video content. So the peak that we see here could be that that we're actually encoding the video content at that particular point of the peak, which, as we saw, or sorry, as we'll see in the case of the Avatar video trailer, Blast Extreme does and will fare better. So we come on to that here. So this is the VLC side of things. This is where we're playing the Avatar 1080p trailer, and first of all we're looking at the encoding overhead. So as far as the encoding overhead, again the two are fairly similar, but in the case of Blast Extreme we have peaked at 100% CPU there on the server, but it's an average of fairly similar. But interestingly, in the bandwidth, you can see that for video content, Blast Extreme is almost double the reduction in terms of both the average and the peak bandwidth. So again, that doesn't come as particularly a great surprise if you consider that Blast is based on H.264, which is a video-based codec, whereas PCoIP is a proprietary codec. But I think even interestingly here, it's worth looking at the fact that if we turn on the disable build to lossless for PCoIP, so it's the result at the top, that we do reduce the bandwidth overhead substantially from PCoIP in its default form. So ultimately, if you are looking at video content, then you could argue that turning off the build to lossless and configuring PCoIP will result in greater bandwidth savings to that degree. So they're the results that we assess for each application. Again, not horribly different for each. I think as a summary, it's again clear to see that for video content, Blast Extreme fares better in its current form, whereas PCoIP appears to fare better for things like office productivity workloads. Now, one thing that we didn't include in the test, which was specifically for the reason that we went to external sources for these, are the hardware encoding tasks of the Apex and the NVIDIA grid encoding, and they're on the next slides to give you really a kind of overview as to how well each will fare, whether you go with PCoIP and the Apex card or whether you go with Blast Extreme and the NVIDIA card. So as mentioned, what we did was we went to basically both sources. So for Teradici, we went to that for looking at comparisons for the Apex card, and we went towards NVIDIA for looking at comparisons specifically with the NVIDIA grid card for encoding Blast Extreme. So this is the result of a blog which Teradici released back in October 2016. And interestingly, you can see that this same graph was based on an office productivity workload, as we've seen in the examples that we've supplied. And also it's important to state that these results are based on Horizon 702. So it is important to state that because Blast Extreme was first made available at Horizon 7.0, VMware in the background have been heavily developing enhancements and improvements to the way in which Blast Extreme reduces the amount of overhead in terms of both CPU and bandwidth. So even today we're at 7.1, and we'll see some even further savings that can be made with Blast Extreme in the latest version. So do again bear in mind, if you are doing a deployment of Horizon, look at the specific version that you're planning to deploy and implement, because the later if you are specifically looking for the Blast Extreme side of things, that later version can potentially provide you with greater savings in terms of bandwidth and CPU overhead. But just to look at the results here, we can see that for an office productivity workload, as we saw in our results, that that in the Blast Extreme side of things, if you're encoding in software, that Blast Extreme is almost 20% higher than PCoIP. And where we use that, we convert that same workload to the hardware-based offloaders. So in the case of PCoIP, it's the Apex card. We can see the savings that we can expect to see by deploying the Apex 2800 card, and likewise if we're using Blast Extreme, if we're using the NVIDIA grid card. So you can see that the overall effect is the same, but obviously the savings are far greater if we're using Blast Extreme, which is quite interesting to see. Likewise, on the bandwidth side of things, similar to what we saw in the PCoIP side of things, this is the amount of relative network bandwidth that we're using for that same office productivity workload with UDP. And if we compare that to Blast Extreme in the software model, it was a little bit higher than it is with PCoIP. If we then offload that again to hardware based, we can see that the Apex card does increase that overhead slightly, but the additional overhead generated by offloading that to the NVIDIA grid card is fairly significant. So I think again it's interesting to see what further savings there can be in the later versions of Horizon with Blast Extreme, specifically with those NVIDIA grid encoders. If we then look at some NVIDIA collateral, this is a comparison of running specifically a 3D workload, Acacia, where in the green here we're seeing CPU overhead of encoding on a server with the NVIDIA grid encode versus the blue, which is the PCoIP form. So again, you can see that the savings provided by the NVIDIA grid encode are very good. But I think one thing that isn't clear in the example here is whether in the comparison of PCoIP, which again is the blue line, whether that's based essentially on PCoIP in its software form or hardware encode form. And again, similarly from NVIDIA, where we see the amount of bandwidth that is generated again if we're using hardware encoding. Now, interestingly here, although the green line here that we see is the encoding of the NVIDIA grid hardware encode, and the blue line is PCoIP. So whilst it's fairly clear to see that the overall effect is reduced with NVIDIA encoding, there are some fairly significant peaks that we see here in the green. So we can see some fairly significant peaks where it peaks quite a bit higher than PCoIP in its form. So some interesting third-party results there from both NVIDIA and Teradici. Now, we're getting towards the end of the comparison of the protocols, and one thing that has emerged very recently, and VMware released Horizon 7.10 last week, and as mentioned briefly, VMware are continually evolving and enhancing the Blast Extreme protocol. And part of that offering in Horizon 7.10 is BEAT. So it's the Blast Extreme Adaptive Transport, where VMware are offering up to 6 times speed and 50% bandwidth savings with BEAT. So fairly obviously recent news to the market, and it'll be interesting to again do the comparisons of both protocols in Horizon 7.10 to see again how the two fare. So you might have reached the end of the presentation, and you might have lots of questions. You might have more questions than when the presentation started, and again we'll have an opportunity to open that up at the end of the presentation, but I think it's useful just to wrap up a few of the key points that I can certainly bring from the analysis that we did. So as far as PCoIP, I think it's clear to see that it's the recommended protocol if you're working in the lossless model. So again, if you're looking at doing deployments for graphic design, for medical imaging, because of the fact that that you can still encode in hardware with the lossless compression, and PCoIP is built for that type of use case by default. It's essentially also a cost-effective model for customers if you aren't looking to deploy VMware Horizon specifically with NVIDIA Grid, because remember, NVIDIA Grid is as great as a overall solution it provides, it does add a additional amount of overhead cost in terms of the CapEx model of the card, and then the additional ongoing licensing costs. And again, it is with PCoIP you have got that option of the Apex 2800 card, which is exclusively a hardware encoder and does have that dynamic ability as well. On the client side of things, if you're looking at the decode side, then if you're looking specifically at Teradici Zero clients, then that's great because they give good hardware decode support. But if you're looking at PCoIP with PCs, with laptops, with regular thin clients, then again, ultimately you have to remember that the PCoIP is supported, but it's in a software form. So to match that same level of user experience that you'd expect in a Teradici Zero client, make sure that you're considering an absolute minimum of a dual-core CPU. If you're looking at providing any sort of multimedia delivery and you're looking at software-based clients for PCoIP, then really you need to be considering quad-core as an absolute minimum to give you that same level of experience. If you're looking at Blast Extreme, remember that you need to have a minimum of Horizon 7, preferably the very latest incarnation to get the latest in terms of bandwidth savings. And ultimately it does work better when it's used in conjunction with NVIDIA Grid, again because of the fact that you can then offload the encode tasks to the card. And again, Blast Extreme is there to provide a very good or an option for if you're looking to deploy Horizon with essentially mobile client devices. So if it's to home users with things like tablets, Chromebooks, laptops, anything that runs off battery, you will ultimately get a greater battery life by connecting with Blast Extreme than you will with PCoIP. And also your inexpensive client devices that don't necessarily support PCoIP well. And likewise, finally, if you're looking to deploy VMware remotely either through the cloud or simply from home type, small office, home office type locations, then deploy it with Blast Extreme. But I think the important thing to really emphasize here at the bottom is that Horizon 7, the whole point, whilst there's a lot of talk and debate about PCoIP and Blast Extreme, remember the fact that you can choose the best of both. So Horizon 7 is really about providing the a use case, a solution for each. So there's solutions for PCoIP, there's solutions for Blast Extreme, and ultimately you're not tied to any one. If you're deploying Horizon 7, ultimately you can pick and choose the protocol based on the user requirements and ultimately the client device or the server device, etc. So hopefully that'll help with a bit of wrap up. Now I just want to finish off the webinar with just giving a bit more of a background to Tenzig Technology. So Tenzig Technology are a solely focused thin and zero client vendor. So whilst there are other thin and zero client vendors out there, Tenzig are fairly unique in the fact that we are solely focused, and this is all we do. We basically live and breathe thin and zero clients. We're headquartered in the USA, and our head office is in the UK, which is where I'm permanently based from. But today I actually am based in the Phoenix, Arizona office, which is where I got confused by the time where I introduced the webinar by saying good morning. So hopefully that explains the reasoning behind there. We were founded in 2003, and we were formerly known as Bossa Nova. So we came originally from an IBM marketplace where we were developing terminal emulation hardware and software, and then we evolved into being a thin and zero client vendor specializing in VDI. We were a founding VMware and Citrix Ready partner, and we are long-standing sponsors of the vMUGs, the virtual machine or the VMware user groups, and we hold full certification for VMware. So we have a complete certified thin and zero client range, which is on the VMware marketplace, and our sales teams based in the UK and our technical teams based in the UK are fully certified for VMware. So a little bit more about the VMware partnership. So as I mentioned, we have VMware Ready certified clients. They include the Teradici clients and also the software-based zero clients that support Blast Extreme and PCoIP out of one box. And we also offer thin clients, traditional thin clients that run either Linux or Windows. As mentioned, we are an original member of the VMware Ready program, and we are also a member of the VMware User Group Executive Board. And we have a very good, close working relationship with Teradici, again, the owner of the PCoIP protocol. And it is important to state that our products, we do offer products that support all of the different protocols that we've talked about today. So ultimately, if you are engaging on a project, then engage with the specialists at ThinkS3, and they can pull Tenzig in as well to qualify and recommend the right product for the right fit. Just a very brief product overview. As mentioned already, something I haven't also mentioned is PC repurposing. So whilst we offer different degrees of thin and zero clients, we also offer PC repurposing. So if you are looking to deploy VMware with PCs and essentially repurpose those into thin clients, we can offer solutions there as well. And this is a very brief overview of our Teradici based zero clients. So we hold probably the widest portfolio of Teradici clients out there that cater for various different use cases. So we offer dual screen clients, quad screen clients, we offer PoE options, fiber options, so various different Teradici based clients if you're deploying exclusively PCoIP. And on the software zero clients, we offer two distinct products that enable you to support both PCoIP and Blast Extreme off of the same box. So we have the 4448V, which is our dual core client. That's this particular product here. And we have our higher end products. It's the 5848QV, which is our quad core unit. So this is generally used for task worker, knowledge worker scenarios, either for PCoIP or Blast. And this is for your high end knowledge worker, power worker type use cases. And that's really it. I very much appreciate everybody's time today, and I hope you found the information that we've presented today to be useful and helpful. And I'm now opening up the table to ask any questions. I can see I've already got a couple of questions here that have been asked during the presentation, which I'm just going to look towards. Just bear with me a second. And Liam, is there anything else that you'd like to just cover before we open out?
No, just really say thank you to you, Kevin, while you're having a look at those questions. And thanks to everybody that's attended there. I hope you've all found it useful and obviously got answers that you were looking for around the protocols for PCoIP and Blast Extreme. As Kevin said, if you do have any further questions, if you want to find out more about how Tenzig solutions are going to fit into your business plans, to what you're doing with your IT, please get in touch with Tenzig, get in touch with ourselves here at ThinkS3, and we'll be more than happy to provide you with any information that you need, be it something specific, or if you're looking at something a bit more general as you're planning and putting ideas together. Obviously, we'll be sharing the slide deck with everybody that's logged on today, so you'll all get a copy of that. You'll have details and a route to get through to Kevin, to myself here at ThinkS3. So back to you, Kevin, if there are
thanks, Liam.
Questions.
Yeah, thank you. So we've got a couple of questions here that have been asked, and again, anybody else that wants to ask any questions, feel free to ask them through the question panel so that I can answer these. So the presentation, as Liam said, we can send this out, and we are recording the presentation today, so we can send a copy of that afterwards. And we have another question here that looks like the protocols are still improving and developing in terms of performance. How does Tenzig plan to keep up with these changes, and how often are feature updates and new releases provided? So it's a great question. So as I said before, Tenzig are a VMware Ready partner. So whenever a VMware are releasing a new version of Horizon and the clients that go in conjunction with those, they basically give us early access to those clients, typically a couple of months before they go to general availability. So we'll get early access to those in terms of what improvements and what changes are available in those newer versions of clients, and that enables ultimately Tenzig to get ahead of the game so that we can learn any new techniques that we have to do to tune those on our client devices. And the way that we bring those to market are we basically wrap those into our thin and zero client. So on the software zero clients and the Linux-based and the Windows-based clients, we will basically wrap those new clients into either firmware or image and make them available to our customers, and then our customers can either choose to update their clients either through our management tool or via USB sticks. On the Teradici side of things, that's ultimately controlled through Teradici. So as new firmware is available with Teradici, then that's made available in a similar way so that customers can upgrade the Teradici clients through the management tool. So yeah, Tenzig are very much proactive in that sense, and we typically are one of the first thin client vendors to be able to offer the latest and greatest support. And we are just in the process now of releasing the Horizon Client 4.1, which was again just released on Friday, I believe. We also have another question that's asking if we have a client that supports both PCoIP and Blast Extreme in one. And again, very good question. And hopefully that was covered at the end of the presentation. So if you are looking at a client device that does support both Blast Extreme and PCoIP, then you're looking at these two clients. So you've got the 4448V and you've got the 5848QV. Now, again, the main differentiators between the two are that the smaller unit has the dual core processor, so it's aimed at your published apps and your task worker environments, and the larger product is the quad core processor that can deal with the knowledge worker and power user requirements to do the heavy grunt work in terms of decode of PCoIP and Blast. We have another question about if I choose to roll out PCoIP, am I locked into that, or can I switch to Blast? It's again another great question. So in that capacity, the protocol is selected generally in the Horizon server. So when you set up a desktop pool, the desktop pool can be configured to either offer one specific protocol only, so again either PCoIP, Blast Extreme, or it can allow the user to choose the protocol. So it ultimately allows both cases really. So if you choose to exclusively lock into one and then switch that later down the line, you can do. And ultimately, if you want to have a desktop pool that allows both protocols, then you can allow that based on the client type to choose that protocol. So that's how it again scales out very well to again consider somebody like using Blast Extreme on a laptop versus somebody in a local WAN type environment to use something like a Teradici client or a software zero client for PCoIP if that's your chosen protocol. Let's see if we have any more questions. Might be one more coming in. Okay, so we have another question here that says around, you showed some H.264 encoding performance with NVIDIA. How do AMD FirePro and Intel Iris Pro encoding offerings compare, or is it very similar? So again, and then we also have, I'll come to that second question later. So that's again a very good question. So it's important to state that if you want to do hardware encoding with Blast Extreme, the only option available to you is NVIDIA Grid. So if you choose something like AMD FirePro or Intel Iris Pro, those products are exclusively there for graphics workloads. So it's basically rendering only. What happens for those options down the line obviously remains to be seen, but as of today, the only product that supports hardware encode are NVIDIA Grid cards. So again, if you were looking at something like AMD FirePro or Iris Pro for your graphics side of things, then it might suit better something like PCoIP, where you can then use the Apex card to offload the protocol and then retain the graphics rendering in the AMD and in Intel Iris Pro. And then so the second question, I think linked to that, is additionally, can you use this hardware to leverage H.264 decoding inside VMs before it is re-encoded and sent off to clients? So with that in mind, with regards to the VMs don't do any decoding. The VMs, i.e. where the source is, the source only ever encodes. Once the protocol is encoded, it's sent down the wire, and it's strictly the client device, i.e. the endpoint, which is either a thin client, zero client, laptop or PC, that deals with the decoding. And on the decoding side, it's again, if it's Blast Extreme and you're decoding in hardware, then you need a H.264 compliant hardware, or if it's PCoIP and you're decoding in hardware, then it's a Teradici client. So let's just see again if we have any other questions. So I think that looks as if that's all the questions we have today. So thanks again everybody for joining. As Liam said, if you have any other questions that you'd like to follow up afterwards, feel free to either reach out to myself or the guys at ThinkS3. And thank you very much for your time today. Thanks everybody.
Thank you, Kevin.
Thanks, Liam. Bye.